Hello, and welcome to this lesson introducing alkanes. In this lesson, we will first understand what an alkane is, then explore the structure and general formula of alkanes, before learning to identify and name different alkanes. So far, we've discussed crude oil and its fractions. Building on this foundation, today's lesson will deepen our chemical understanding by introducing alkanes, a specific type of hydrocarbon. Understanding alkanes will help us comprehend more complex organic molecules and reactions in the future. Let's get started! Alkanes are a homologous series of hydrocarbons, which means they are composed solely of hydrogen and carbon atoms. What makes alkanes unique is that they are saturated hydrocarbons. This term saturated indicates that alkanes contain only single bonds between their carbon atoms. No double or triple bonds are present. This single bond structure defines how alkanes interact and react with other substances. A single bond is a type of chemical bond where one pair of electrons is shared between two atoms, in this case, between two carbon atoms or between a carbon and a hydrogen atom. Single bonds are the simplest and most stable type of bond. In contrast, some other hydrocarbons contain double bonds, where two pairs of electrons are shared between atoms, or even triple bonds, where three pairs of electrons are shared. These multiple bonds make molecules more reactive. In contrast, single bonds are quite stable and require high energy to break. As a result, alkanes do not easily participate in chemical reactions except under specific conditions such as combustion. In summary, alkanes are less reactive than most unsaturated hydrocarbons. We'll return to the more reactive hydrocarbons that contain double bonds later in this unit. The general formula for alkanes is CnH2n+2, where N represents the number of carbon atoms in the molecule. This formula is crucial because it helps you to determine the number of hydrogen atoms in an alkane based on the number of carbon atoms. For example, if N equals 1, then there would be 2 multiplied by 1, plus 2, which equals 4 hydrogens, corresponding to a formula of C1H4, or CH4. In terms of structure, alkanes have a chain-like arrangement of carbon atoms. Each carbon atom forms 4 bonds in total. In an alkane, each carbon atom bonds to other carbon atoms and hydrogen atoms through single bonds. This means every carbon atom is either bonded to 2 hydrogens, if it's in the middle of the chain, or 3 hydrogens, if it's at the end of the chain. The naming convention for alkenes follows a straightforward system based on the number of carbon atoms they contain. Here are some examples: methane, which has 1 carbon atom, ethane with 2, propane with 3, and butane with 4 carbon atoms. The names of alkanes all end in A, N, E, and the prefixes are derived from Greek or Latin prefixes indicating the number of carbon atoms. Let's take a brief look at the structure of those 4 alkanes. Methane is the simplest alkane with the molecular formula CH4. It consists of 1 carbon atom bonded to 4 hydrogen atoms. The carbon atom is at the center, and the 4 hydrogen atoms are evenly spaced around it. Ethane has the molecular formula C2H6. It contains 2 carbon atoms connected by a single bond. Each carbon atom is bonded to 3 hydrogen atoms and to another carbon atom. The structure is straightforward: CH3CH3. Propane's molecular formula is C3H8. It has 3 carbon atoms forming a chain. The carbon atoms are bonded by single bonds. The first carbon is bonded to 3 hydrogen atoms, the middle carbon to 2 hydrogen atoms, and the last carbon to 3 hydrogen atoms. This is often written as AH3CH2CH3. Butane, with the molecular formula CC4H10, consists of a chain of 4 carbon atoms. Each carbon atom is bonded by single bonds. The first and last carbons are each bonded to 3 hydrogens, and the 2 middle carbons to 2 hydrogens each. The structure can be written as CH3CTH2CH2CH3. In today's lesson, we delved into understanding alkanes, a specific type of hydrocarbon. We learned that alkanes are saturated hydrocarbons, meaning they contain only single bonds between carbon atoms. We also examined their general formula, CnH2n+2, and learned how they are named. We then visualized examples of alkanes. We will dive deeper into the properties and reactions of alkanes in upcoming lessons. Watch the rest of the GCSE Chemistry course at Sophos Education.